Once again, hello everyone. Officially, I begin my presentation. Please subscribe to our channel, POSITEV. As you realized, you can get a free ticket for PhD. We have various memes. What else we're going to talk about? But first of all, let me introduce myself and my colleague who is going to help me. I am Vladimir Kochetkov. I am head of Department of Expertise of Application Security and Code Analysis Development. So if you get 1,500 falses from us, it's my fault. And my colleague, who is head of one of the groups of developers of Code Analyzer, Sergey. Welcome, Sergey. Thank you. He will take the second half of the presentation, the demonstration as such. And I will introduce the problem. If you want to work with us, if you are interested in what I'm talking about, the technology, the company, good technology, good company, this is the QR code, and under it, it's my personal mail. We have a few vacancies for developers, experts. Probation is possible. Please write to me and we shall discuss it. What is the problem? What are we going to talk about? Why do we think that the code request language is not required? Look, actually, Application Inspector exists from 2013, and from that moment, summer 2013, it always had DSL for code requests. Most of the users didn't know about it, but this DSL has been changing from time to time, but it exists. The first DSL looked like this. It's a little bit improved regular expression. You can see the yellow strings. You can identify what kind of IST type we're talking about. And this template matches all kind of variables. It's hard-coded password. There is a weakness, hard-coded password, and this is the template for it. That was the first language. It doesn't exist anymore. Its history is quite interesting. I will tell it tomorrow at the party. If you are interested, ask me. Later, at 2015, we replaced it for another expression. It matched IST of all the languages which were supported, approximately the same kind of template, identifier, password, PVD, and some variables. It exists from 2015, but we were not ready to show it to the users. When we abandoned YAR, we picked up this DSL. Before that, it was supported in the module, but not in the interface. Of course, as soon as we started working with the users, they asked us a lot of things. Please do this, do that. As far as request languages are concerned, the first request was about taint model. What is a taint model? We have input, output points, and the filtering function. Taint model means that we analyze the code about the data from entry point to exit point. Can they get there bypassing the filters. We can have different functions, different points of input points, output points, filters. The users wanted, without waiting for us, without waiting for a new release, fill in the knowledge base with their data. So we developed the SAST v1 language. It was in the product, it was used. It was rather primitive, JSON, a simple one. We can say that there is a user print function. If you find it, then it will be potentially dangerous. We could also introduce filtering functions. What kind of risk class, risk level? Simple. There was one big fault here. Any user print function was detected and there was a false positive, but still users liked it. A new request came in. Let us join DSL semantically and non-semantically. This is semantic DSL. We are talking about semantics, not about syntaxes. And this is the syntax. This is the way it should look in the text. Let us merge syntax and semantics. As a result, we have SAST v2. It's in the release. All the kernels of the analysis code before this year, C#, Java, and PHP, support this. It looks like the previous one, but as you can see, you can enter syntax templates for taint analysis. So taint model expansion problem was solved here, although we had more requests. This is not a taint model. It's only the interpreter which works with the memory model. But Georgi will tell you later in his presentation about it in greater detail. For the model to work properly, we often need to describe new frameworks about dangerous functions, for example, and we have to describe links between objects. The heaviest functions should be defined by some links without analyzing the whole function, but just use the link, and you shouldn't jQuery analyze in each request. Express.js or jQuery. This language didn't allow us to do that. It didn't allow us to describe links between objects. As a result, in parallel, we started working at SAST version 3, and as long as we worked, we had another requirements that all this should be available for every possible programming language. Python, Java, C, everything. We have to cover semantics of all the languages. And we faced quite a lot of problems because semantics in different languages quite different. They dynamics and statics, typization, JavaScript, for example, and others. They are different, and we stumbled and we couldn't finalize version 3. For example, all this which you see now describes just one entry point only. All these strings. This is horrible. It's very difficult to write, it's very difficult to read, and it's very difficult to implement because we couldn't support all the languages we wanted, and we abandoned version 3. We stopped working on it. And then a major requirement, why taint model only? For example, we want to work with business logic. Each business logic has its own formal model, and we have to describe it. We cannot have a universal model for any kind of business logic. All the logics are different. parallelism errors cannot, so taint model cannot work with it, with parallelism. So all this, in principle, is not the right direction to develop the expandable and convenient analyzer. And then we said, let's not bring about new SAST requirements in version X. We decided not to generate more languages, more requests, and approach and choose a quite different approach. Let me answer the question, why reinvent the wheel? Why not take another model? We have a lot of models like that. Of course, we have to name it differently. For example, SemGrep, CodeQL, they are excellent tools. Excellent tools. I'm quite serious about it. Any specialist should master those tools. They cannot replace each other in all the cases, but this is an excellent article comparing SemGrep and CodeQL. Please read. Good article, good comparison. Both tools ran on the same project to compare them, and then you can see the results. What is better, what is worse? SemGrep is better. The author says it's arguable. Of course, it's controversial. If you look carefully about both, you will see one interesting thing. Common injection, very low percentage, 11, 12, it's bad. Insecure cookie, higher, good result. LDAP injection, low. Well, if we compare everything, vulnerability, syntax vulnerabilities can be found here. Semantic vulnerabilities show us low results. Injection, for example, what kind of grammar, what kind of filtering functions, what is the grammatical context. As soon as we see that question, so the results are low. I didn't see application inspector, but our result is not lower than 90% everywhere. I'm not showing it to you to avoid advertisement problem. What is wrong with OWASP benchmark? Not deep 3, no. Well, we have little time left. Java is a good language. The problem is not in Java. Java is a static language. It's very easy to analyze. Call graph is done by compiler there. It's designed in such a way that you can get call graph very easily in dynamic. Try to do it in JavaScript. It's impossible as soon as we use dynamic injection of you cannot build call graph. It's a good program, but it's written on Java. It's for statistic languages only. We have our own set of tests. Of course, we cannot compare it with OWASP, but there, all the tests are focused on semantic support. We have an article now we have for PHP. Right now, very soon you will have for Java, JavaScript, C, and later Python and others. So I used the same tests here. I don't show you the results. SimGrep found only one non-HTTPS. It didn't see anything. CodeQL found everything, even something which was not necessary. Any potentially dangerous functions, regardless of filtering, limitations, he just showed us false positive. SimGrep false negatives, CodeQL false positives, so use them together. Why didn't we take their model? We don't want to make our model weaker. We analyze better. Just take our code, compare our analyzer and them. I don't show you the results, I'm quite sure of them. CodeQL and SimGrep do not suit us. They are focused on their own models. So what is our approach? How different it is? We believe it's the right approach. We have only the prototype of that solution. Sergey will show it to you later. But it looks as if we found the right way. What is the purpose? Why do we have to allow the user to write his request? What kind of user, what kind of task is it? We want a simple thing. We want to take the expert component of our product and demonstrate it. It's a knowledge base. It's something that our technology works with. What kind of data we have. So what does the expert component of the analyzer consist of? It's the model of application. With SimGrep, it's syntax, taint model, syntax with the data flows in between. With SimGrep, CodeQL has a bit different model. We have a calculation flow model. It's the most extensive model for a statistic analyzer. From our model, you can take and get all other models. It's the widest of all. We need a tool to make it narrower, even that. The second component is the threat model.
It's what we're looking for. Not some specific functions or object fields. What determines vulnerability classes or superclasses. An injection, whether through XSS or path traversal or LDAP injection, the model is the same. So an injection is one vulnerability type. Parallelism is a different issue. Cryptography, as Dmitry Sklarov was presenting, is a whole different world. Different models, different access models, discretionary, etc. Mandate models. Business logic is almost every application is a model in itself. There are countless models there. And finally, the third component is classification objects, how we link the codes to vulnerabilities. Those are calls on functions, links between objects, etc. And it looks that we can externalize all of this, at least in our analyzer, based on its architecture. Our analyzer works as follows. It's not an architecture, it's a working process. So what happens when we tell it to analyze the code? Depending on the language, we work differently with its presentation. Some languages use abstract syntactic trees, others use our own syntactic tree, yet others are compiled into bytecode and analyzed in this form. But in any case, any of these three presentations is a full-scale interpreter of that language. There's GSA, there's a memory model, and interesting entity is a package processor. That's what intercepts some events of interpretation, such as changed object fields or changes in functions, and helps do something to do something with the function. We can create a process that in the memory model would emulate the call on this function, or we can return an expression as a result of the work of this function. So the package processor is the core of our knowledge base. And this is presented in a nice way, that this is an entity in itself, but actually package processors can reach out to a variety of areas. And we thought, why can't we allow users to write package processors? How do plugins work? You know that in NumPy or in Java, you can write a plugin which receives the HTTP query, and then you can do anything with it. You can write your own logic. Nothing prevents us from doing the same. And this is what we did. And the package processor part started looking like this. We have extension scripts outside of the analyzer that have access to a special extension API. And this extension API helps have almost full control of the analysis. If you want to add support of a new framework, it's very straightforward, and Sergey would give you a case of that. And you can try and implement a new class of vulnerabilities based on our model, or you can try and detect some coders' errors in security. So essentially, this extension API gives you almost full control of the virtual machine. Question becomes how brave you are, so to say, to understand how it works, because the technology is quite tough. So what we did, instead of the code query language, we developed a set of plugins to the interpreter that help enhance its functionality almost without any limits. The scripts are written in C#, and we are thinking of adding F#, but it's not a given, and also perhaps supporting Python. Hackers are more accustomed to Python rather than C#, and this is one of our target audience. And you can use those scripts to change how the interpreter behaves. And you can have access to all of the primitive elements of the system. It's almost that you could write your own interpreter in that script. Unlike SemGrep and SQL, this includes script debugging, and Sergey will show you. There are debuggers, and you can do that. And those who wrote serious queries in CodeQL would know what I mean. There's no debugging. And if your query doesn't work, okay, that's as much as we can do. You go and figure it out. We can't really support you here. But with us, you can really review that. And thus, we can expand our expert components. We haven't done it yet, but we are on the way. And now I'm giving it over to Sergey. head of the development team who implemented this, and he'll pick it up from here.
Вот, всем привет.
Hi, everyone.
Самая простая часть этого доклада.
As
Видео у нас должно быть чуть
as Vladimir explained, this is the simplest part of the presentation. The video will be a bit later. Please put the presentation back up. So what we did to demonstrate, we wrote a very simple framework for a web app consisting of two classes, each of which has a method and two additional functions. We have a class for describing incoming requests from which you can get a parameter, a response class to which you can send an answer. And because we're smart, we know about security, we know about the needs of firewall for HTML, and we have a function for that. And the final element that brings it all together, that's an entry point. If you have a path on a server, how do you process the request that goes there? How do we describe this in our script extension language? This is a simple application using this framework, a number of query processors. The first is not very secure, gets the response, gets the parameter, and sends it to the outcome as is. The second one is more secure. It gets a parameter, it filters, it sends a query. The third one has a condition. It gets one parameter, and depending on the condition, it runs an SQL query and sends the result back. And this then goes into three different paths for processing the queries. So how would this work? We need to describe two classes. We describe the class of query. It has a certain method. The method has a name and what should happen when it's processed. We want to look at the arguments, we want to understand the name of the parameter, and to return the value, marking it that it is derived from a certain parameter. Quite straightforward. The second class, response class. There should be a method sends. We want to check what's the input and whether we can put it into the output. So there's an expression you want to check, and we're checking for XSS, and this expression might end up in HTML. Another level of sophistication, that's when we link the vulnerable points of query classes and response classes. There's an entry point, and the second argument wants to call with certain parameters to be interpreted, and so that vulnerabilities could be detected. We create instances of the query class and response class. We tell our machine that we starting to analyze the entry point, and it has a certain path if we know it's from the signature, and that a certain function with certain arguments has to be implemented. And finally, the simplest example, how we filter expressions. If we get an expression into our function, we mark it, label it with a certain property, and we tell it that there's a certain grammar that has been filtered, and we won't find the vulnerability in this case. Okay, now time for the demo. Let's now run the video. Can you please run it from the very beginning? Thank you. Okay. So we have the plugin that our colleagues did, and we reported about it a year ago. Okay, here's our expression. Let's do a scan and let's see what the outcome is. Okay, we found 3 vulnerabilities as expected. The first one, the path is this, the parameters are that. The second one is with a condition, and the third one also with a condition. An example of debugging. In the same code, we can open our script and write this magic method wait debug that would wait for a debugger. That's very conveniently we can also refer to from this environment. So here we can see what are the inputs. And we can see that one of the inputs is an object that is tainted, that comes from outside, because we developed those objects in another development environment. So here we have 3 calls, and we can see what arrives there. And finally, we get an expression which has a condition. And there are 2 options. One, we can see that is tainted and the vulnerability is positive. And that's the end of my demo. And that's the end of my presentation as well. And that's the end of the whole presentation. Thank you very much. Thank you for your attention. Happy to take your questions.
Да, сейчас, одну секунду можно. Ну, давайте микрофон.
Okay, please bear with us for a second. Let's wait while the person is getting the microphone. As I explained, there will be a prize for the best question. Yes, hi. I wanted to ask what was missing for me in the presentation. Where are your rules? Are there any rules? Are there any scripts? Are there any default scripts for supported languages? So where are the rules? Answer. There are no rules. The rules remained in SAST v3. We don't have them anymore. The code that Sergey was showing is the product. And how do you supply it? We don't supply it. It's still a proof of concept. It hasn't been released yet. But certainly we will be sharing some of our knowledge base as scripts. In fact, most of our knowledge base. And as recently discussed at our channel, there would be some public repository where it would be possible to exchange plugins. Thank you for your question. Thank you for your presentation. What if the code has an SQL inclusion, truncate database, inclusions in other languages? Answer. That's a very good question. Technically, nothing prevents us from switching analyzers between different languages. Our architecture makes it possible in principle, but currently it's not implemented, and I hope you won't ask the question why at this point. Okay, thank you. Thank you for your presentation. I have a question on one of the statements that I saw on the slide to the effect that we will allocate expertise and people and give them the interface so that they supply their expertise there. And my question is, so what did you mean by that? In other solutions, expertise is some knowledge about these are sources, this is something that is not so secure, something about taints and things like that. And it seems that this is not entirely OPSEC. Okay, I understand the framework and I understand where the critical spots are. So what did you mean? Answer. Okay, let me give you an example. There's this famous here in Russia 1C product, which has an engine written in some ++ language, and it can be configured in their language, which used to be in Cyrillic. Now it's evolved. So whatever was written in that language in 1C, the accounting records, the invoices, so that's what expertise is. That's written by someone who first understands the subject matter, and only in the second place the AI programmer. But those who wrote the engine are not experts, they are not accountants, they were coders. And so this is what we mean by externalizing expertise. We have very good guys who are skilled hackers who work with us, but never have the skills of writing industrial codes. But then we have developers that can write very good industrial codes, very high-load, high-performance codes, but they don't understand much about OPSEC. And we really want to differentiate between that, so that where it requires more OPSEC expertise, you would have the relevant people, and on the development side, you would have people with more expertise in development. So yes, currently at this point, you've got to be a C# developer to use our engine to describe an externalized expertise. But as I said, that's currently a proof of concept at this point, and we'll do our first release, and then we'll try to address or switch to Python. And a short question as a follow-up. Do I understand it correctly that by releasing this functionality, you would give an opportunity to say, if we developed our own DSL and we use your API, and then our knowledge and expertise can be incorporated through this scripting interface? Is that what you are doing? Are you essentially giving us a little bit of your machine, and then we can turn it into the shape that is comfortable for us? Yes, exactly. And not just a little bit of the machine, but all of the machine. Okay, thank you. There are two people there, and I guess those would be the last questions, because we have to be mindful of the time. Yes, hi, thank you very much for your presentation. Really, your ideas resonated to me. I wholeheartedly agree with that. And my special thanks for debugging, because in OpenQL, in CodeQL, debugging is a huge issue. But what QL is good about, because at one point they developed their own CTF, or whatever was the name, in which in a short period of time a lot of rules were written, and they promoted that. So if you give away your expertise, if you give away your database, similar to CodeQL, into open source, is your plan then to quickly provide rules to your parser, so to say, through contests? Well, let me be humble and concise here. Yes, we do. That is the plan. We want to work through our community, but a little bit later, when it's implemented. Because currently we only have interim builds, but soon we'll have it. Okay, the next one, just over there. Yes, hello, thank you for the presentation. Very insightful. I have a practical question about the comparison between the two tools that you mentioned. On SamGrep in particular, I was surprised that SamGrep found very few hits, which I guess conceptually shouldn't be there, because SamGrep has a large community. It has a lot of rules, and you can load up to 1,000 rules, or you can load 1,000 rules for various languages. And for me, the outcome with that, in terms of false positives, would be SamGrep would be much more of the suspect than CodeQL. Okay, thank you for the question. As for SAMGREP, the only dangerous and vulnerable function that we had in our data sets, it was described there. What it didn't address, didn't address the link between the input and the output. We're talking about SAMGREP for taint analysis, not about signatures. Yes, oh yes, okay, I can see where you're coming from then. Okay, thank you. And let's take one final question from this gentleman here. He's had his hand up for quite a long time. Yes, hello, thank you for your presentation. I'm new to all of this topic, and maybe I have a stupid and naive question, but you say that you're giving all of the machine to external developers. Are you not afraid of a situation when you would need an analyzer for your analyzer? Like an elephant in the cupboard situation. Well, we are confident of our own cupboards. As for other cupboards, yes, you've got to know what you are doing. The deeper you go into the models and machines, you've got to really understand what you are doing. But I don't think you'll be able to do anything fatal. You know, nothing would explode, nothing would break physically. It's ordinary development. It's more of a question about support and documentation, and we are not there yet. No, we are not afraid of that. We don't see a big issue there. Thank you. Sergey, what question did you like best? Well, we've got to pick one. I liked the question of this bloke over there. Did you? Yes. Okay. Do you want to pick two? We've got to pick a question. Okay, there's one. Anything else that comes to your minds, and we can award 2 prizes. Okay, so the winners are that question from over there and the question about the elephants in the cupboard. Okay, thank you very much and goodbye.